Welcome to Algebra 2, Unit 6, Lesson 11, Practice Problems. In this lesson, we're going to look at what happens when we move around the circle clockwise rather than counterclockwise. And we're going to look at the difference between positive radian angles and negative radian angles. So the first question says, for which of these angles is the sign negative? So the first thing we need to pay attention to is that they want sine. And sine refers to the y value. So if I want sine to be negative, I need to be below the x-axis down in quadrants 3 and quadrant 4. So if we draw our unit circle, we are used to normally starting at point P and rotating counterclockwise. And when we rotate counterclockwise, we have positive angles. However, we could also start at point P and we could rotate clockwise. And if we rotate clockwise, we're going to have negative angles. So when they're asking if angles have a negative sign, we are going to take those angles rotating clockwise, and they will need to be on the bottom half of the circle in either quadrant 3 or quadrant 4. So the first point we have would be negative pi over 4. So negative pi would rotate clockwise to the halfway point. So negative 1/4 would be this point right here in quadrant 4. So this is negative pi over 4. And at this point, y would be negative, so sine would be negative, and A is a correct answer. The next one, B, is negative pi over 3. So this is going to be 1/3 of the way to the halfway point on the bottom half. So it's going to be right next to pi over 4. And we have negative pi over 3. So B is also a negative sign because the y value is negative down in quadrant 4. Now we can look at C. C is negative 2/3 pi. So we are rotating clockwise, and we are going to rotate 2/3 of the way to pi. So we would be down here in quadrant 3. This would be negative 2/3 pi, and C is also correct. Choice D, we are now at negative 4/3 pi. So we're rotating clockwise, and 3/3 would take us all the way to pi. So 4/3 takes us another third of the way up. Now we are in quadrant 2. And in quadrant 2, sine is positive because y is positive. So D is not correct. And our final point, E, this is negative 11/6 pi. So the negative says we're rotating clockwise. Going 6/6 would take us to pi. And then we have another 5/6. So we almost complete a full rotation. We're over here in quadrant 1 at 11 pi over 6. And for choice E, sine would be positive because y is positive. So E is not correct. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Plot each point on the unit circle. So for point A, we have an angle of negative pi over 4. The negative tells us we're rotating clockwise, and the pi over 4 tells us we're going 1/4 of the way to pi, which is a half circle. So if I want 1/4, then my point is halfway through quadrant 4. So this would be point A. For point B, we have an angle of positive 2 pi. That means we start at the right, we make one full rotation counterclockwise, and we end up back at our starting point. So this blue point is B, 2 pi. Point C, we have positive 16/3 pi. "16 divided by 3 is 5 and 1/3 pi. For C, we're rotating positive. That means we're rotating counterclockwise. So one full rotation would be 2 pi. 2 full rotations would be 4 pi. Half a rotation would be 5 pi. And now we need to go down one more third. And our point would be in quadrant 3. This would be point C. And finally, we have point D. This is the same as C, only now it's negative. So instead of rotating counterclockwise, we're going to rotate clockwise. One full rotation clockwise is 2 pi. A second full rotation clockwise is 4 pi. 5 pi would be rotating half the circle to be here on the left. And this time we're going up another 1/3. And point D would be up here in quadrant 2. So the negative tells you you're rotating clockwise. The positive tells you you're rotating counterclockwise. Pi is a half circle. 2 pi is a full circle. And then you can divide it into the fractions from there. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. The clock reads 3 p.m. Which of the following are true? Select all that apply. A. In the next hour, the minute hand moves through an angle of 2 pi radians. Now, initially, you might think that it's true because it would move one full rotation around the circle. But you have to remember the minute hand is going to rotate clockwise. So if it rotates clockwise a full circle, it's not 2 pi radian, it's negative 2 pi. So A is wrong. Choice B. In the next 5 minutes, the minute hand will move through an angle of negative pi over 6 radians. So it will move from this point at 12 over to this point at 1, and that is negative pi over 6. It is 1/6 of a half circle, and a half circle is pi. So B is a correct choice. Choice C. After the minute hand moves through an angle of negative pi radians, it is 3:30 p.m. So this means we've moved from the top of the clock and we complete a clockwise rotation of a half circle. So now the hand would be down here at the bottom. That's negative pi. And that would be 3:30 p.m. So C is a correct answer. Choice D. When the hour hand moves through an angle of negative pi over 6 radians, it is 4 p.m. So this says the hour hand is going to move from 3 clockwise to 4. This would be negative pi over 6. So D is true if the hour hand moves negative pi over 6. It would be 4 o'clock p.m. And choice E, the angle the minute hand moves through, is 12 times the angle the hour hand moves through. And what they mean is that in 1 hour, the minute hand will move from 12 clockwise all the way back around to 12. So it will move 2 pi. But in that same 1 hour, we just said the hour hand would only move from 3 to 4, which is negative pi over 6. So in 1 hour, the minute hand moves 12 times as far as the hour hand does. So E is also correct. The only choice that was not correct was A, because they said it would move 2 pi, and it actually moves negative 2 pi because it's a clockwise rotation. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Which of these statements are true about the function f given by f of theta equals sine of theta? Select all that apply. So when we have a graph of sine theta, we have the y-axis and we have the theta axis. And because this is sine of theta, it is going to start at 0 on the y-axis, because we're starting out at the right side where x is 1 and y is 0. Now this is a unit circle, so we have 1 at the top and we have negative 1 at the bottom. And then we could have pi over 2, pi, 3 pi over 2, and 2 pi. And then the same thing going the opposite direction. So, when we draw our graph, we start at the origin because it's sine. It goes up until we're at 1 at pi over 2. We come back down to 0 at pi, down to negative 1 at 3/2 pi, and back up to 2, or back up to 0 at 2 pi. And then we do the opposite in the other direction. So down, back up to 0, up to 1, and then back down. So this is the graph they're talking about. So for A, the graph of f meets the theta axis at 0, that's at the origin, at plus and minus pi, plus and minus 2 pi, and if we kept going, it would also hit at plus or minus 3 pi, and it would be the same way for every whole number pi. So A is a correct choice. B, the value of f always stays the same when pi radians is added to the input. Well, here, if we were at pi over 2, and we added pi, that would put us at pi over 3. But we can see that instead of staying at 1, it's actually become negative 1. So B is incorrect. C. The value of f always stays the same when 2 pi radians is added to the input. Because 2 pi is a full circle, it brings you back to where you were previously, so you always get the same result. On this graph, you can see if I go from negative 2 pi to 0 to 2 pi, my value is the same. If I go from negative 3/2 pi to positive 1/2 pi, my value stays the same. And down at the bottom, if I go from negative pi over 2 to positive 3 pi over 2, my value stays the same. So C is correct. The period for the sine function is 2 pi. So you're always right back at the same point with the same value. Choice D. The value of f always stays the same when negative 2 pi radians is added to the input. Well, this is the same thing, only now you're going from right to left on this graph, or you're going clockwise on the unit circle. You are still saying the period is 2 pi or the period is negative 2 pi. They both result in you being at the same point again with the same value, so D is also correct. And choice E, the graph of f has a maximum when theta equals 5 pi over 2. Well, if we go by this graph, we are at the maximum, which is 1, at negative 3 pi over 2, and at pi over 2. Well, if we added another 2 pi, that would put us at 5 pi over 2. That would be up at 1, so that would be a maximum. On a unit circle, 5/2 pi is at the top of the unit circle in the same place that pi over 2 is. If you have any questions about how I answered this practice problem, please use class time to ask for further clarification. Here's a unit circle with a point P at 1, 0. For each positive angle of rotation of the unit circle around its center listed, indicate on the unit circle where P is taken, and give a negative angle of rotation which takes P to the same location. So for point A, we are going to pi over 4 radians. That is 1/4 of a half circle. So point A would be right up here in quadrant 1. If I want a negative angle that will put me in the same spot, I need to subtract 2 pi. Well, 2 pi equals 8 pi over 4. So if I take pi over 4 and I subtract 8 pi over 4, my new angle would be negative 7 pi over 4. Point B, pi over 2 radians. That is half of pi, which is half of a half circle. So that puts us at the top of the circle for point B. Now 2 pi written as halves is going to be 4 pi over 2. So to find my negative angle, I'm going to take pi over 2 and subtract 4 pi over 2. This leaves me negative 3 pi over 2, which would put me in the same point. Point C, pi radians. That's half a circle counterclockwise. So my point is on the left side of the circle for point C. If I want my negative, I take pi and I subtract 2 pi, which equals negative pi. That would take me counterclockwise half a circle and put me in the same spot. And finally, point D, this is 3 halves pi. 2 halves take me halfway, and another half brings me to the bottom of the circle. So point D is at the bottom of the circle. And again, we already said 2 pi written as halves was 4 pi over 2. So we're going to take 3 pi over 2, and we're going to subtract 4 pi over 2. And we end up with negative pi over 2. If you have any questions about how to plot positive radians or how to find their negative counterparts, please use class time to ask for further clarification. List 3 different counterclockwise angles of rotation around the center of the circle that take P to Q. So for number 1, if we go 1/2 rotation counterclockwise, we end up at Q. So the first angle, I would say, is pi. Now next, I could take pi and add 2 pi because I'm going to go a full rotation, and that would give me 3 pi. So that would be 1 full rotation and a half rotation to end up back at Q. So pi just takes me here, and 3 pi brings me around and back to here. And next, I could just add 1 more rotation, and that would put me at 5 pi. That would be 1 full rotation, 2 full rotations, and then the final half rotation to put me at Q. Number 2. Which quadrants are the angles 13 pi over 4 and 10 pi over 3 radians in? So, 13 divided by 4 equals 3 and 1/4. So, 1 pi takes me halfway, 2 pi brings me back to where I started, 3 pi takes me halfway, and 1 more fourth puts me down here in quadrant 3. So 13 pi over 4 is in quadrant 3. Is the sine of these angles positive or negative? Well, sine is the y, and in quadrant 3, sine is negative. Next, we have 10 over 3. That equals 3 and 1/3. So 1 pi takes us halfway, 2 pi brings us back to the start, 3 pi takes us halfway, and 1 more third brings us just past it. So this is 10 pi over 3. So again, 10 pi over 3 is in quadrant 3, and since sine is y, sine is negative. If you have any questions about how to find repeating positive counterclockwise angles, or if you have any questions about how to plot angles, determine what quadrant they're in, and whether sine is positive or negative, please use class time to ask for further clarification. Our final practice problem for lesson 11. In which quadrant are both the sine and the tangent negative? Well, sine equals the y value, and y is negative in Q3 and Q4. Tangent equals y divided by x. For this to be negative, one of them needs to be positive and one of them needs to be negative. So y over x is negative in Q2, where y is positive but x is negative, and Q4, where x is positive but y is negative. So the one that they have in common is Q4. So sine and tangent are both negative in the fourth quadrant. In the first quadrant, sine is positive and tangent is positive. In the second quadrant, sine is positive. And in the third quadrant, tangent is positive. If you have any questions about how to determine whether sine or tangent are positive or negative in each quadrant, please use class time to ask for further clarification.